right, so here we are. Welcome back to Majestic Hats, and we are going to take some time to talk about logarithms today, a very important topic that a lot of students have trouble with, remembering what logarithms are all about and how to handle the questions. And I'm hoping that this video becomes as popular as Justin Bieber's Baby Baby video, or at least that Waka Waka video by Shakira, or Shatira, whatever her name is. So logarithms, let's really get into it here. To understand logarithms, I wrote some stuff down ahead of time. Logarithms are exponents. That's the number one fact that you have to remember, and I'll constantly refer to back in this instructional video about how to handle logarithms. That logarithms are exponents. Whenever you see a logarithm, it means it's talking about an exponent. So the first thing to understand about logarithms is how to make a switch from something called exponential form to something called logarithmic form. And the reason why we want to do that is to actually bring the exponents down to the base. So right here we've got 2 to the y equals 7. The base is 2. So if we want to change this into logarithmic form, we'd say log of base 2. And logarithms are exponents. So I'm starting to write a logarithm statement here. Logarithms are exponents. So what is the exponent over here? It's y. Now I'm left with one other piece of that equation that would have to drop right there. When you read this, you can read it as 2 to the y equals 7. Or y is the exponent that we raise 2 to become 7. You can also do it with equations that just have numbers. Like 10 to the third is 1,000. That's a fact. What is the base here? The base is 10. So you could write log of base 10. And logarithms are exponents, going back to the very first statement. So I'm writing a logarithm. What's a logarithm equal to? It's always equal to the exponent. The exponent's 3. And then that 1,000 would just go there. Now, this is a special logarithm. It's called the common logarithm. It shows up so often in math because we've got 10 fingers, that 10 is a very popular number, that eventually we just don't even write that 10 down. It's understood that when you don't have a base written there, you're talking about the common logarithm. And actually it's so special that we actually have a button on our calculator for the common log. For this one here, that's e to the x. That's Euler's constant, which is a special number just like pi is. If you rewrote that in logarithmic form, the base here, the base is on the bottom, is e, and the bottom here is right here. So that's where we put our base. Logarithms are exponents. The exponent on this side is x. So we know that x is going to go on that side there because logarithms are exponents. And then the 12 would end up over here. Now, this is such a very common, I shouldn't use the word common, this is a logarithm that shows up quite often. Often enough, it's actually called something very special called the natural logarithm. And the abbreviation for that is ln. And then almost always, this will be rewritten like this. All right, so that's a quick walkthrough of the basics. Moving down the line here to the next mini part of the lesson is talking about logarithm properties. And logarithms give us the ability to break up a complicated logarithm statement into 2 simpler ones. So the log of a times b is equal to the log of a plus the log of b. If you have the division, a logarithm of a division of 2 pieces, you can break that up into the log of a minus the log of b. And it's because logarithms are exponents, there are these properties associated with them because there are properties associated with exponents. And then for this one right here, this is the most powerful of the bunch here, I would say, is that if you have logarithm of an item to an exponent, that you're allowed to bring the exponent out in front of that logarithm statement. And it doesn't matter what, oops, I didn't take it down. It doesn't make a difference what the base is. The base could be anything. I mean, the bases could be 7 all the way across. The bases could be 10, not even written there. Or there could be ln instead, or the base could be, 2. So it doesn't make a difference what the base is. Those properties always hold. And then usually I'll tease you on an exam or a test with one that it's all kind of messed up, like the natural log of x to the third times y over the square root of z. And they'll ask you to break it up into smaller pieces or to expand the logarithmic form. So in a question like this, you would break it up as the ln of 3 plus the ln of y minus the ln of z, the square root of z. And that'd be the first move you could make to start simplifying it. And then you can use that last property and bring those exponents out in front. So this would be the same thing as 3 times the ln of x plus the ln of y. And z, the square root of z is the same thing as z to the half. So that half can be brought out in front. Big recommendation on a question like this is that make sure you take your time with it and not try to do the whole thing in just one big move, but take the smaller steps first, especially if the denominator is complicated. And as far as these properties go, sometimes you want to take a complicated expression like this and break it into smaller pieces, and other times you want to join these pieces together to go back into that form. It all depends on what you're trying to do. Now remember, you can always pause the video at any time if you have questions, if you want to replay something, if you didn't quite hear what I was saying because I was going too fast. I'm trying to jam this all in maybe less than 10 minutes. So here we are in the last bit here. Is actually using logarithms to show you that logarithms are very helpful in actually accomplishing some tasks. The reason why we're going to use logarithms here, the logarithms are going to come to the rescue in a question like this because we're trying to get at that x which is trapped in the exponent. And you could try to get a common base occasionally, but there's no common base that you could create that would have with using just the numbers 6 and 18. So to actually bring the exponent down, what we're going to do is a popular math move is take the logarithm of both sides. Whatever you do to one side, you have to do to the other side. And once you accomplish that, you can use the properties of logarithms that let you take the exponent and bring it down. So logarithms are like a ladder that let you climb up and bring down the exponent and drop it down in front. So once you get that far with the question, there's only a couple more steps left to do. One is to get the log of 6 to the other side. So you divide both sides by the log of 6, which would give you x plus 2 equals the log of 18 divided by the log of 6. And then subtract 2 from both sides. Now the only thing stopping you from getting the question right now is just failing to type it into the calculator correctly. Make sure that you put the 18 in parentheses and the 6, and notice that you're never going to do log of 18 divided by log of 6 is the log of 3. So don't be tempted to divide those there. From there, it's just using the calculator. You've got your log button on your calculator. You can just type it in, the log of 18 divided by the log of 6 minus 2. So just like that. Gives me about negative 0.39. So how do I know if I solved the question correctly or not? What I can do on this calculator here is I can store the answer. This is the easiest way to check your work. You can store by pressing the store button. Store the answer as a letter. So I stored it as x. So anytime the calculator sees an x now, it's going to think it's that number, negative 0.39. And now I can go back to the original equation and type in 6 to the x plus 2. Hit enter. says 18. Mission accomplished. All right, I was interrupted there for a second, but now I'm back to finish this question for you. So we're trying to solve an equation that has two logs in it. One thing you can do to make it less complicated is create it where there's only one log. And we saw a second ago that you could take the log of two statements that are being multiplied, or if one statement is being multiplied and change it into addition. You can also go in reverse. You can take two separate logs and bring them together and make them a single log with multiplication in the argument over here. So this would be the same thing as the log of 5x times x minus 1 equals 2. You could distribute the 5x through. And now it gets us to our next dead end. To get past the next phase and actually get the x away from that logarithm, we can change it into exponential form, which is the very first thing that I showed you. The base here, this is the common log, so you'd have to remember that the base here is 10. So the base is 10, so if we rewrite that in exponential form, we would have 10 to the, well, what is the exponent? Logarithms are exponents. So this is an exponent because it's a logarithm, and it's equal to this, so that has to be the exponent because logarithms are exponents. So you'd write 10 squared equals 5x squared minus 5x, and now what you've created is you've created a quadratic equation, and all you need to do from there is solve it by factoring or the quadratic formula. You get 100 equals 5x squared minus 5x. You can subtract 100 from both sides. And then I see that common factor of 5 that I can draw out of there. So I would bring out a 5. And then luckily for us, this is one where you could finish it off by just factoring. So it would be a negative 5 and a positive 4. You finish solving the equation and you get two answers, 5 and negative 4, which brings us to the last part of the lesson. When actually you're solving a logarithmic equation, you always have to check to make sure that you do not get answers that do not make any sense at all. And whenever you have a logarithm with a positive base, it is impossible to get a negative number sitting to the right of it. So I know that if I use negative 4 in this equation here, I'll get something that I can't do. The log of negative 20, when I plug the negative 4 in, would not compute. There's no answer. You could try it on your calculator and it'll say, no can do. The 5 actually does work out just fine because the log of 5 times 5 is the log of 25. You just type that in. The log of 25 is all that. And then plus the log of 5 minus 1 be the log of 4. So I could do plus the log of 4. Ta-da, equals 2. I know I got the answer right. So remember, when you're solving equations, regardless of what kind of equation it is, a linear equation, a quadratic equation, a trigonometric equation, an exponential equation, a logarithmic equation, any equation, you can always check the answer. With logarithmic equations, you must check the answer. So good luck with your math studies, and remember, if you've got questions, just post them to me or send me an email, and I'd be happy to help you out and give you a video explanation if possible. But I've been helping out some students who I don't even know, which is nice. I like to help out people. So good luck to you, and stay tuned. We'll see how long the beard actually gets. I guess we'll find out in the future if I shave or not. But stay tuned. It'll give you a reason to keep on coming back. And I'll push the video. Tell your friends, and hopefully it'll be a very good experience for you to actually have. You can rewind it and play it again if you enjoyed it so much. And I think it was a pretty good explanation in a short period of time. So good luck to you.